Okay. Share screen. Share entire screen. Yeah. Let me know if you can see that.
We've got you.
Got it.
The text big enough?
I can zoom in a little, or I can zoom in on my end.
There's a zoom. So.
I got it.
It's on the bottom there, but I can zoom in here too.
Yeah, we got zoom on our side.
Sounds good. All righty. Need to open a new terminal. There we go. So, CB desktop. Okay, cool. Python 3 desktop. All righty. So we talked about variable assignments and declaration. And declaration is just like declaring the variable, which you can't even do in Python. You actually have to assign it. Or assign/define, both the same thing. So we're assigning 1 to A, or defining A as 1, however you want to say it. Then we talked about control flow briefly. We're going to talk about loops today. We're going to talk about functions today, and maybe, depending on how far we get, we'll get into some OOP stuff. So we talked about this control flow, but control flow goes beyond just if statements. Like you can have a bunch of if statements. Like I can just copy this over and over again and just have if. And in which case, what's going on over here? This might be a Macism. User bin Python 3 test .py. Is that what we did last time? Oh, I'm not in desktop. That's fine. There we go. And then you'll just, you end up printing as much as you want. So if statements are contained, Python is white space sensitive. So like the shift, the one tab shift, is how it knows something is like contained within a function. Other languages have curly cues. The way I would describe programming is it's kind of like learning a bunch of different variants of Chinese. Once you kind of know the basics, then like you can navigate around the different dialects of the region because they're all pretty similar along these structures. This is Python's variant. So the other piece to if statements is else's. So ifs are basically a control flow that, if something's true, then it will run the statements within. If it otherwise, meaning if this is not true, then at the end, it will print test. Let me get print test here. And so if I change this to be like if A equals B, which is not going to be true, I think I got to do equals to say equals within a if statement, then I get test. However, I can also layer in additional statements through something called an if-else statement, which you specify it as if-else. You specify it as elif, elif, but it's an if-else statement. So if else, else. I'm just allowing you to control the flow of execution of a program. So in this particular case, B is greater than A, but if I say A is greater than B, then this if-else statement should run. Boom, we have if-else. Does that make sense? So what happened here is it ignored the first one because the conditional was false. The second one ended up being true, so it ran this one and then stopped execution for the control flow. So one if-else all the way through can only run one of those like sub sequences. Once it finds one that's true, it doesn't run anything else. Does that make sense?
Got it. Yep.
Sweet. Alrighty.
Yeah.
So I guess one point to know is because of this, there's like loads of variants of if else, and I'll show you a couple. But like because of this, if you want to check if a bunch of things are true, but not just one of them is true, you actually have to just use a sequence of if statements. You can't use if else because it will only run one of those statements, and it will actually stop checking after that. So if I wanted to also check like elif b is greater than a, print b greater than a, it actually won't run that. It will stop right there at that line. So you would have to change these to if statements in order for that to work. Now if I ran it, well, b has to be greater than a. Let me say a is greater than b. Now if I ran it, I get both because they're just if statements that run in isolation. Okay, that's the basics of that. We'll leave it there for the moment. Other things to note is you can have very long expressions up top that are along these lines where you add in logical operators in between your conditional operators, and b is not equal to a. It's actually the word and in Python. What's it arguing at me about? Expected pilots. I have an extra. Oh, hold on. I think I have a syntax error there. Oh, that's a minus. It's supposed to be equals. There we go. Let me do this. Parentheses are always a pain. The extra parentheses here. Okay. So this is like two comparative operators with a logical operator. So what it does is it evaluates each thing, kind of like classic math with parentheses first, and then it will evaluate and says that both of these have to be true in order for this statement to run, right? So it won't run. It goes to the next line, which ends up being true, so it prints if else. But the other thing, so there's a bunch of variants. The reason this can't be true, obviously, is because you have a not expression with a equals expression. Those can't both be true. But if I change it to or, the other logical expression there, it is true. And so basically, oh, sorry, hold on. Oh, a equals b or a equals b. We'll do one more because that's actually not true. If a is greater than b, right? So any of these three now can be true, and it will be true. So the last one's true. A is greater than b. The whole statement's true, and then it goes in here. Something else that is worth noting is you can always evaluate things like outside of there. So if I want to say like, I want to simplify my code, I can say like x equals that, and x will come back as true, and you'll get the same result. It'll just fill it in there. So you can do all kinds of fancy things with control flow. It's extremely useful. I'm trying to think. So the last thing we didn't talk about is the logical operator not, which is literally the word not in Python. So now this says, if not, this whole expression, it basically says flip this whole expression. So if this is true, then if not true, it will come back as false. So right now, it jumped to the second line, if else. It didn't run this expression because this inner expression evaluated to true, and then it said not true. Does that make sense? Give me a verbal thumbs up or something. I can't see you guys on my screen.
Sorry. Yeah, that makes sense.
Cool.
Yeah.
So logical and comparative operators are really key here for control flow. So we'll move on. So you've got your basic variable assignments and declarations. You've got control flow. Now let's talk about loops. Loops came about because there are sequences of programs that you just want to run over and over and over again until some condition happens. There are two loops that are primarily used. One is called for loop, and one is called while loop. We'll do for loop first. For loop syntax in Python is a little bit weird, I'll admit. It's range 0 to 10. Just set one up here. Ooh. What did I miss? Oh, for I in range 0 to 10. Print test. And I'm actually going to just, I'm going to comment out these print lines so that we don't have that stuff print up top. All right. So focusing here, now we run our item. Ooh, what did I mess up? Oh, it's saying I have to have that. Let's just comment out all the extra text here. Oops. Right. So that text is commented out. That won't run. Now we have for what else am I missing here? Oh, I'm missing this syntax. There we go. Alrighty. Save, run. Okay, so test prints out 10 times. What this is saying is that for I, which is a variable, in the range from 0 to 10, do something 10 times. The real way that you'll see this in C++ is like for, I think it's for like I equals 0, I, 2I less than 10, I plus plus. It's just kind of weird syntax in Python, so I want to show you this. What this statement is saying, range is a function. We'll talk about that in a second. That's basically like giving you a sequence of numbers, and then I is a variable that you're setting. What it actually is in most programming languages is this, which is for I equals 0, so I starting at 0, 2, I is less than 10, so stop running when I is equal to or greater than 10. I plus plus, meaning increment I each loop. That's really strange, but it's supposed to say like start, stop condition, and then like the change condition for each time it runs the sequence that's underneath the for loop. Does that kind of make sense? This is weird Python syntax for that.
Yeah, that makes sense.
Okay, cool. If it doesn't, let me know. I'm just going to comment that out so that you have that. But so typically what you're doing is you're using I within the code somehow. So here's an example. I want to print out 1 through 10. And I don't want to print out, go like print 1, print 2. That's way too much work. So instead what we do is we have these for loops and we can print, oh geez, what's going on here? Just do it. I might have to do strings. Just do that. Just do string. Oh, I don't have the let's print it. There we go. So I don't think I actually had to do string there, but so it prints out 0 to 9 because basically it starts at 0, it goes to 10, it goes, it goes to 10, but it stops like basically. I think this actually says it goes 10 times is what this basically says. But since it starts at 0, it ends at 9 because it's 0 through 9. Oops. I changed the code there. And so you can do all kinds of fancy stuff with for loops that are phenomenal. For loops, the reason you use a for loop, for loops are for when you know how many elements you need to loop through ahead of time. So if I know I'm going to loop 10 times, or when you know how many elements you need, then you're usually better off using a for loop. So it's a little bit more readable. The other loop is a while loop, and while loops are the same thing, except they're for when you need to loop through something when you do not know how many elements you need to loop through ahead of time. So the way while loops are written in every language, including Python, is typically while some expression is true. So I'm just going to actually put in the Boolean true. Booleans are ones or zeros or true or false. So while something is true, kind of like an if statement here. While something is true, do something. So I'm going to print out test. And I need a colon here in Python. No, colon there in Python. Okay. So there we go. Oop. I gotta manually kill it here.
No, that one would never end, right?
So it never ended, right? It was going to go on forever. I had to like kill the process. The way that you typically do this is you sometimes you say while true, and you can have this thing called a cool break statement in here. So that's one way to do it. And break, as soon as the line break is hit, it stops. Fighting Mac a little bit here. What is going on? Let me do this. There we go. I gotta get on the desktop and see the desktop. Okay. All right. So so we'll even comment out this this for loop up here. Save. All right. So it just runs once because it hit the break statement. I could do something that's like I'll show you that in a second. That's actually really hard to do. First off. So a lot of ways you'll see this written as well. I is less than like 10, for instance. You have to declare I before, or define I beforehand. So I'm going to say I is equal to 0. So while I is less than 10, I want to print test. Now, if I just run this as is, I never changes because I never changed I in the loop. So it will actually run forever. What you need to do is you need to come in here and say I equals I plus 1, which basically says I want you to take the current value of I, add 1 to it, and I will get the new value of I. So now, make sure it's saved. If I run this, why are you doing this to me? Hold on a second. Copy this just so I have it saved. There we go. Now it runs test 10 times. And I could, I can do a million different things like plus string I and print out test. Do that. Say print I test, and I could, add anything together. You can also do the reverse. You can do decrements. So you can say, well, I is greater than 10, and you can start at 11, or you can start at like 20 and go down to 10 and say I equals I minus 1, so that you're kind of decrementing each time what I is. And in which case it starts at 20 and it kind of goes down to 11. So there's a lot of different variants, but these are the two loops that are pretty common. I can also have control loops in here that basically I can do some fancy stuff like this is going to be true, right? I've declared I out here as 0, and I'm incrementing I by 1. Could increment it by 2. I could increment it by anything. And I want to, what do I want to do here? I want to say if I is greater than 5, I want to break. So this particular case will do, oh, get out of here. Copy, paste. We'll do 0 to 5 or 0 to 6. So the second that I was greater than 6, it broke, but it printed 6 before it broke. So does that make sense? There's a lot of different variants you can do, but the basic structure is this.
Makes sense.
Yep. Makes a lot of sense.
All
This
righty.
is fun. I like learning this.
Rachel, I would highly recommend Code Academy too. I don't know if you've heard of
Oh,
that,
yeah.
Ron, but
I remember that from college.
I paid for like I don't know, it's like $70 for the year, and did the Python one. And it's like, you don't need an executable, like it's all web-based, and it kind of walks you through a lot of this stuff, and you solve some cool problems. So if you like this, I remember that's what got me into doing some of this, and it was super fun.
Yeah, I totally forgot about that.
Awesome. Awesome. Congrats, you're learning Chinese. You'll be able to speak computer science here soon. So functions. For loops and while loops are actually kind of like internally functions, but not exactly. So a function is, we learned pretty quickly that if I have some basic procedural code like you saw up here, but I want to reuse something that's pretty similar to that code, it's a lot of work to just copy and paste that code, tweak it, copy and paste, copy and paste, copy and paste, copy and paste into infinity for all the different things that I need. So what we decided to do was we decided to come up with functions, which are basically templates of this type of code that I could kind of reuse anywhere. And so a function in Python, it looks like this. I'm going to do a simple add function. C equals A plus B. And then I'm going to do return. I'm going to do C. Okay. So the add function adds. So let's go over the structure here. So def just says basically function in Python. The add is the name of the function. It's what you're going to use to call the function. I'll show you the call here in a second. Let's do add. Let's do d equals add, and then let's do print d. It's the full thing. So we have this template up here. Same white space sensitive situation. Add is the name. A and B are what are called arguments. That's the name for variables when they're inside the parentheses of a function. These arguments are basically the inputs to a function. So it's just like y equals mx plus b. X is the input. So like these are the inputs to a function. It's got two inputs.
Ron, A and B here in the add function don't have anything to do with the A and B defined
Correct.
above, right?
Correct. They have nothing to do with the A and B above because they're declared within the add function. Also, I commented out the A and B up here. But even if I did, it wouldn't matter. We haven't talked about scoping, but things that are within functions are scoped within that function, not outside the function. However, there are some ways to edit things outside the function from within the function. Different languages handle this differently, but this particular A and B being on the right-hand side of this expression, not being assigned in here, meaning that these are arguments, and the fact that they're on the right-hand side rather than the left-hand side, you wouldn't be editing outside of it. Now, if C is declared somewhere else in the program, globally, meaning it's just like at the top, like this, C equals C, this will override what C is here for the whole scope of the program. I think in Python, unless C is a variable here, you can get very complex with these things, and scope always matters. It's a good thing to be aware of. But for the sake of this, you have two inputs, and then return is what you're returning out of the function. It's the output of the function. And so for this particular function, I have A and B, and I'm adding A and B together to C, and then I'm going to spit C back out. How do I spit C back out? How do I get it back out, right? Because what the code's going to do is it's going to execute along my cursor. It's going to see this. It's going to say, okay, cool, there's an add function. I'm going to ignore that. And then it just, literally the interpreter will say, I'm going to ignore that for now. It's just a template. Then it comes down here and it says D. D is being defined as A or as add. Oh, I need to, as add 1 and 2 as the assignments to the inputs. So it's like, I need to go find that. Then it will go back up to line 40 and it will say, I found add, the same name. Cool. So A is going to be 1, B is going to be 2, and then it's going to go through here and it's going to say C is 3, return C, and then it's literally going to evaluate this to C, and then D is going to be assigned C, and then D is going to be printed. So if I do this, 3 is printed. Does that make sense how a function works?
Yep.
Now you can have functions called within functions. So you can do like fancy function, fancy function. We'll give it t and y as variables. And I'm going to add another function up here that says def subtract. It's going to be a and b. We're going to subtract them. C equals a minus b. Return C. And then within the function itself, fancy function, we are going to call those two functions and say h is equal to add 1, 2 plus subtract 9, 8. And then we're just going to print it within the function. We're not even going to return it this time. So this is my fancy function. I have to call my fancy function. Actually, just going to do this. I realize we have like 1 minute here to screen. Okay. And then we're going to print. I'm going to print, and then I'm going to do fancy function a 1 or 3, 4, and then we'll say ty and ab. ty, and then we'll just do something like that. Okay. So voila, it printed. Fancy function doesn't return anything. So inside the function, we printed 5 because that was what the math came out to be, and then we printed nothing because fancy function doesn't return anything. Cool. Well, that's probably all the time we have for today. Any questions here?
No questions
No
here.
questions.
Thanks, Ron.
Awesome. Sweet. Then OOP next week when we get over there.
Alrighty. Happy Friday.
Yeah, happy Friday.
Friday.
Yes.
All right. We'll see you guys.
Man,
You didn't get him. I was waiting to see if you'd get him. Oh
I
man.
was clicking it. My hand was up.
I could see in your eyes that you were just like you were just trying to get
I
off.
was like, where's the button? Okay, bye. I'll see you.
All right, we'll see you.